Hey Pre-Calc, welcome to week 2 of remote learning. This week we're going to be talking about section 5.5, which are double and half angle identities. Today we're just going to focus on some double angle identities. So let's title our notes 5.5 Day 1. Solve an equation using double angle identities. So close. And today is April 27th. Alright, so we're going to start by going over the double angle identities. I would recommend after or while I'm going through them, if you want to write it in your notebook, great, but you should probably also write them on a note card. That way you can use them during the quiz. So the double angle identities, there are 5 of them. The first one is sine of 2 theta equals 2 sine theta times cosine theta. There's only 1 for sine. There's 3 for cosine. So we have cosine of 2 theta equals cosine squared of theta minus sine squared of theta. Then we have cosine of 2 theta equals 2 cosine squared of theta minus 1. And cosine of 2 theta equals 1 minus 2 sine squared of theta. And then the tangent double angle two tangent of theta all over 1 minus tangent squared of theta. So those are the double angle identities. So you could pause the video and write all of those now on a note card so that you have them all in front of you, or you could do that later. Basically, for solving an equation, we want, it's very similar to what we've done in the past. We want to write the problem, or rewrite, I should say, in terms of one trigonometric function. So that's what we were doing in the past, especially in 5a. You want to end up setting it equal to 0 and then solve. So we're going to do one example and then a you try. Let's do cosine of 2 theta minus cosine of theta equals 2. So, I need to give you what theta is an element. So theta is going to be between 0 and 2 pi. Be very careful. You need to pay attention to what theta is. We sometimes like to change it up. For example, we'll make it between like 0 and 3 pi over 2 or something like that. Okay, so some of you might immediately think, hey, we could factor out a cosine, but unfortunately we can't. Hopefully you know why, and it's because this is 2 theta and this is theta, so they are not the same. It's not like we have a cosine squared. So if this were cosine squared of just theta minus cosine of just theta, then we could do factoring. Okay, So what you're going to do first is you need to change this cosine of 2 theta using one of the double angle identities. So now you have to look at the cosine ones, and there's 3, and figure out which is best. So remember, if we want to write everything in terms of one trig function, and we only have cosine right now, right off the bat, this one right here simplifies to be 2 cosine squared minus 1. So that seems like a great one to just go right to. You could potentially use others and then use your other trig identities that you know, but that would potentially be more difficult. So now I'm going to rewrite it using the identity. So I'm going to rewrite here, I'll color code, cosine of 2 theta. That's going to be rewritten as 2 cosine squared of theta minus 1. And then I'm going to bring everything else down. I'll do it in orange. So minus cosine of theta equals 2. So my goal is to solve. And remember, so everything is in terms of one trig function. That's great. We do want to set it equal to 0 so that we can solve. And we want to try to not cancel things out. So I'm going to bring that 2 over and do a little bit of rearranging. So this is 2 cosine squared of theta. I'm going to put my minus cosine theta next, so my numbers are all together. And then I'm going to subtract 2, and negative 1 minus 2 is negative 3. Now, hopefully, because you see we've got 3 terms, and the first one is squared, not scared. Sorry. We are hopefully thinking of u substitution. If you are, great. If you're not, well, I just said it, so now you're probably thinking about it. So we can let u equal cosine. And then we can rewrite this as 2u squared minus u minus 3 equals 0. And then it's just a factoring problem. So if you want to remember factor by grouping, remember we have our a times c up here and our b down here. So this is negative 6. Our b value is negative 1. So what multiplies to negative 6 and adds to negative 1? Hopefully you're thinking negative 3 and positive 2. So I can rewrite this as 2u squared minus 3u plus 2u minus 3 equals 0. Oops. Factor out the greatest common factor of the two groups. Group 1, group 2. So that's going to be u. And we're left with 2u minus 3. And there's nothing there, so remember just positive 1, 2u minus 3. And then when we factor out that greatest common factor of 2u minus 3, we're left with u plus 1, and those are our two factors. So now I can use the zero product property and also replace u with cosine. So that's going to be 2 cosine of theta minus 3 equals 0. And cosine of theta plus 1 equals 0. And I'm going to solve. So for this one, it's going to be 3 halves. And for this one, cosine of theta equals negative 1. And for 3 halves, you might be struggling, and that is rightfully so, because that's not possible, if you remember. So cosine can't ever be 3 halves. So that doesn't work. It's sad, but true. But for cosine of theta, it can equal negative 1. So what value of theta? And then remember, you need to go back all the way back up to what theta can be. So it's between 0 and 2 pi. What values between 0 and 2 pi give us cosine equaling negative 1? And hopefully you are thinking pi. And we are done. So that's it. It's very similar to what you've done before. The only difference is you're now using some new identities. So why don't you pause the video and try the second example. Tangent of 2x plus tangent of x equals 0. Alright, hopefully you guys just completed this. There are a few ways to do it. I'm just going to show you one right now. And it might be different than what you did, and that's okay. So the first thing we all should have done is change the tangent of 2x to be 2 tangent of x over 1 minus tangent squared of x. I'm just realizing now that I didn't give you where x is an element of. Sorry about that. We'll assume it's the same between 0 and 2 pi. So now some of you may have gotten a common denominator, which is honestly the way I did it the first time last year, but then I realized there was another way that's a little bit less work, so I'm going to show you that. And that actually is first subtracting that tangent of x. So yes, we want it to equal 0 eventually so that we can solve. But if we do it this way, we can kind of be sneaky and just get rid of the denominator by multiplying both sides by the denominator. And then foiling. So then on the left side, I've got 2 times tangent of x equals, and on the right side, I've got, I'm going to FOIL, so negative tangent of x times 1, and then negative tangent of x times negative tangent of x squared. So negative times negative is a positive, and that's going to make tangent cubed. Oops. And now I'm going to move everything back to one side. So if I add to the left, I'm going to add tangent, so I get 3 tangent of x. And then I'm going to subtract tangent cubed. And now it equals 0. And now I've got 2 terms and they both have a tangent in common, so I'm going to factor out the greatest common factor, which is tangent. So when I factor out tangent of x, I'm left with 3 minus tangent squared. Remember, factoring out a greatest common factor is the same as just dividing each term. And now I can go straight to using the zero product property. So that's going to be tangent of x equals 0, and 3 minus tangent squared of x equals 0. So 3 equals tangent squared of x. So plus or minus the square root of 3 equals tangent of x. All of these are on the unit circle. So tangent of x is equal to 0 at 0 pi, pi, and 2 pi. And it's positive or negative root 3, so that's 4 answers. That's going to be, what, pi over 3, first quadrant, 2 pi over 3, 4 pi over 3, and 5 pi over 3. And that's it. Hopefully that makes sense, and hopefully you got those answers if you did this a different way. Your homework will be on the website, and then remember there's office hours and also flex time tomorrow and Thursday. So if you have any questions, feel free to go to one of those sessions and either work on your homework or ask questions. Enjoy the rest of your day.